A lot of cities are trying to move all buses to zero-emission vehicles. When you think about this, though, it's an engineering feat. From changes to the roads, to an overhaul of our national power grid system, changes to personnel, development of new power sources themselves. These are just some of the activities. Here are the 4 big categories of work that need to be done to make this happen, according to the experts.
You're watching S.T.E.M. Today we'll tackle one STEM topic I learned from experts. Just 4 key questions with each answer under 1 minute or less.
Visualize what you would do if you were going to redecorate your house. You don't go out there and just start shopping. You need to think about what you want to get, when you want to transition it over, how the old and the new are going to work together, and then what you're going to do with the old. Well, for zero-emission buses, engineers and city planners need to think through all of the steps that are going to happen as part of this transition. They need to think about the power for the buses, the charging station needs, the what and where of power sources, other infrastructure needs that need to change, upskilling, and impacts from weather changes. And then on top of all of these things, because the technology of the buses themselves is still evolving, they need to make sure that all of these factors have an ability to flex and adapt to future technology. Now, one of the biggest things that they have to plan for is the supply chain. And there's a lot less bus manufacturers than there were years ago. And in fact, diesel buses take about 10 to 16 months to deliver. So cities are having to get really creative with how to actually create these electric or fuel cell buses, including getting kits from Europe. There's obvious infrastructure changes that need to happen, like to the buses themselves or to the power stations that are somehow going to restock the buses with some sort of power. But when you think about electric buses today, a lot of them use the grid systems today, and our US transmission lines are not zero emission. So the biggest changes that need to happen from an infrastructure perspective are the building and upgrading of the US power transmission lines. Now, think about power today. So the power lines today were designed to do flow in a specific direction. It goes from grid to distribution system to the customer. But in the future, you have 2 new challenges because not only are you going to have to use more sustainable sources of power, you also have energy coming from the buses themselves. So now the grid lines need to be able to handle energy coming from the buses into the grid system. And then you also have to be able to account for things like solar energy, where you're only going to get energy during the daytime. So now that needs to be stored somehow in the system and then distributed accordingly. Power sources as they exist today aren't good enough to take us all the way there. So scientists and engineers are in a mad race to improve 2 primary types of power. Battery electric have been around since the late 1800s and have a very long evolution. You replace a fuel tank in an engine with a battery and a motor. Now, what's great about these is they handle idling and starts and stops well, and the maintenance tends to be a lot less. But unfortunately, these don't go as far as traditional buses, and also the battery source itself, which is lithium ion, is extremely flammable. So if it escalates quickly. Now, fuel cell electric have been around since 1966 and were first developed by General Motors. These are self-powered, so hydrogen combines with oxygen to create a fuel cell, which can be used to power the bus and then stored in a battery. Now, what's great about these is these do go as far as traditional buses. Unfortunately, though, the process tends to be very expensive to make hydrogen, and not all hydrogen creation processes are zero emission. So it really only becomes doable if you're doing it at scale. Some of the transportation changes in history, like the move from carriages to cars, involved really big impacts to society because people had to think and behave differently. Luckily, with the move to zero emission, there's not a lot of impacts to you and I, but there are impacts to the personnel that support the bus system. According to the MTA in New York City, which, fun fact, is the largest bus system in North America, there are 4 areas where people will be impacted: safety, bus maintenance, facility maintenance, and dispatch operations. Now, the MTA has to think about how are these roles changing with the new technology. For example, if something's becoming more specialized, they might need a higher skilled worker, or they might need to pay that worker more. Reversely, if something is becoming more simple, maybe they don't need as many people. One of the big things that the MTA is thinking about is the timing of this transition. Because if they were going to try to have the same coverage in operations that they have today and move to electric buses, it would actually require 10 to 20% more buses, which means more personnel. So the timing becomes crucial. Bonus material. On average, it takes about 10 years to get approval for changes to the US power transmission lines because no one wants a new power source or new power line running through the backyard. So not only do you need a lot of time, you also have to have coordination across state levels, national levels, and across private companies. That's all I've got, but if you want some extra reading, make sure to look up the transition for the heavy-duty vehicles like garbage trucks that also need to move to zero emission. Now, don't forget to subscribe, and I'll see you next week.